Okay. Page 459, folks. Look at this picture. This is going back to what you know about parallel lines. Okay? You are given, this is A, C, D, B right here. And then we got 3y and 2y plus 20. Okay? Now, folks, here's the thing. You got to know. You got to know what these angles are. You got to know what's congruent to what. That's going to be helpful to you. A lot of you refer to the zigzag, right? And you look and you go, this is 3y, which means this is 3y, which means this is 3y. Do you guys agree with that? And what it is we're using vertical angles, and then we're using alternate interior, and then I'm using vertical angles again. And now I've got to solve for y. How in the world am I going to solve for y? The linear pair. Right here's a linear pair. A linear pair means add the two angles together and set them equal to what? 180. So here we go. Before I've solved for anything, I have to solve for y. I don't know an angle measure yet, but I'm going to find it. Add like terms, and I get 5y plus 20 is equal to 180. I'm going to subtract 20 from both sides, and I get 5y is equal to 160. I'm going to divide both sides by 5, and I get 160 divided by 5 is 30-something. 32. Sounds good to me. Okay? Y is 32. That's not my answer because number 55 says I need to find the measure of angle ABD, which is 3y. Okay? So the measure of angle ABD is 3y, or 3 times 32, which is 96. Okay? Right? And then we have to find CDB. CDB. Right here. In red. Folks, a whole lot of the problem is you don't know where the angles are. And all it is if it says the measure of angle CDB, I'm starting at C, I go to D, I go to B. Now, it's blank. What is it? It's 2y plus 20. How do you know that, Amber? Because you can zigzag that. What kind of angles are these right here? Vertical angles. They're vertical angles. CDB is equal to 2y plus 20. Don't I already know what y is? Sure, it's 32. 2 times 32 is 64. Plus 20 is 84. Okay? I could almost promise that bell work next week would include something like this. What are we doing with the bell work? Seriously, what is... We're going back and picking up this stuff that we've gone over months ago. Okay? You got to know this. You have to know this. This is the time that this ought to be a piece of cake. You should have every one of the parallel line problems correct. Every one of them. All right, moving on. Page what? 504. Let's look at that. 504, I asked you to do 5 through 9, 5 through 15. 5 through 15, here we go. And I'm going to tell you, I've done these problems twice before. I'm not doing every one of these. Number 5, you should have 1/5. That's rise over run. Number 6, you ought to have negative 1/2. Number 7 is 3 over 2. Just number 6 was negative 1/2. Rise over run. Start from the bottom point. Number 6 is end, so it's the blue line. And you count up 1, 2, 3. So you count up 3, which is positive 3. And then from that point, I count left 1, 2, 3, 4, 5, 6. Left 6. I always, because to me, it's called rise over run, right? How am I going to rise if I start at the top point and I'm trying to get to a bottom point? Does that make sense? I want to start at the bottommost point, and I literally want to rise and then run. So that's what I do. And of course, we're going to simplify 3 over -6 to -1/2. Okay? One too many. All right. Number 8, you should have 54. Because it's not asking for the value of the variable. It says what's the sum of the smallest and the largest part. So folks, when you find the littlest part, you take it and you add it to the biggest part. And the middle part means nothing.
Okay.
It just helps you solve for X or Y or whatever you used for your variable. Number 9 says if the perimeter of the rectangle is 95, what's the length of each side? You should have 17.5 for one side and 30 for the other. Okay? Need to see 8 and 9? 8 is, it said the ratio is 3 to 5 to 6. And if you didn't get this right, I would definitely write this down. 3 to 5 to 6 says if 84 is divided into that ratio, what you're going to do, folks, is you're going to take 3x plus 5x plus 6x, and you're going to set it equal to 84. And now we're going to solve the equation. Adding like terms, 3x plus 5x plus 6x, 8, 6, 14. What's 84 divided by 14? Somebody help me out, please. 6. And then it said, what's the sum of the smallest and the largest? If you look at 3x, 5x, and 6x, which is the smallest? The 3x. What's the largest? 6x. 3 times 6 is what? 3 times 6 is 18. 6 times 6 is what? 36. 54. Shamalama ding dong. Y'all need to bring that word back. I'm just saying. Yes. Shamalama ding dong. You totally need to bring that word back. Yeah.
Somebody else can help.
I don't know why. I would want to be known as the kid who brings back the word shamalama ding dong. Why would you, does that word, why would you not want to bring that word back?
I can't really say it.
I'm just messing with you. All right, so there's number 8. Does that help you? Okay, look at number 9. The ratio, number 9. The ratio of the measures of a pair of sides of a rectangle is 7 to 12. But it's not 7 to 12. We're thinking 7x, 12x, right? Because that's the ratio. And it says the perimeter is 95. Folks, how do I get 95? If the perimeter is 95, don't I have, how many 7x's do I have? 2. How many 12x's do I have? 2. You better be writing this down if you didn't get this. That's 24 and 14 is 38. I think. Somebody punch this up in your calculator for me. What is 95 divided by 38? How much? One more time. 2.5. Thank you. 2.5. What am I going to do with that? Look at it. It says, what's the length of each side? Well, I'm going to take 2.5 and I'm going to plug it back in here. 7 times 2.5. That's 17.5. Is that right? 17.5, and then 12 times 2.5. 24 and 6 is 30. There you go. There are your sides. Guarantee you will see that again. Bell work. Guarantee it. You got to know it. Got to know it. Yep. That's all you do. Okay. All right, and then we had to go to number 10. Number 10, you had 21. Number 11 was 10. Number 12 was plus or minus 6. I need to hear a yep. Plus or minus because you're going to take the square root of 36. And remember, when you take the square root, it's a plus or minus. X squared. equals 36. Did you get that? Did you have x over 4 is equal to 9 over x? Oh, there you go. X times x is not 2x. X times x is x squared. That one's a very simple problem. Number 12 is one you'll see again, I bet you. Number 13 is 13 or negative 11.
Could it be 11 minus 13?
No. It's either negative 11, positive 13. Okay? Did you have your, no. You have your factors right, but now you have to set each factor equal to 0 and solve. Excuse me.
Oh, that's what I think.
Yeah. Number 14, you should have plus or minus 8. And number 15, folks, a lot of you came back and asked me about this yesterday. You should have 3 or negative 5. Here we go. Number 14. 12 over 2x is equal to 3x over 32. Okay, let's cross multiply. 2x times 3x is 6x squared. 12 times 32 is something big. 384, thank you. And then I'm going to divide both sides by 6 because I'm trying to get my variable by itself. 64, take the square root of both sides. X is equal to plus or minus 8. This is not the problem we should be missing. Okay. That one's the one we ought to be getting right. 15. Okay, plus or minus. And then number the other one. Here's the thing, folks. I would prefer, I'm taking up time to go over new material. Okay? Let me give you a helpful hint on number 15. If you will distribute 3 first, and then cross multiply, and FOIL out y plus 1 times 3y plus 3 is equal to 48, then you ought to be able to solve it from that point. This is algebra. All right, you need to go back and try it again and see if you are making a careless mistake. And if you are, then let me look at it at the end of class. It's not that I don't want to answer the question, but we got to get to new material. We've got to get to this new material, okay? Because that is algebra. It's not geometry. All right? What was we had one more, I think? 29 on the same page, or flip it over. The lamppost problem, right?
24.
What page?
507.
507, 29? Jonathan's 3 feet from a lamppost that's 12 feet high. The lamppost, all right, here we go. This is picture. Here's Jonathan. There he is, right? Jonathan is 3 feet from a lamppost. There it is. Lamppost is 12 feet high. You need to draw this picture on your paper. The lamppost and its shadow form the legs of a right triangle. The lamppost and the shadow form a right triangle. Folks, do you see the right triangle? Okay. Jonathan is 6 feet tall. How long is his shadow? All right, his shadow is going to be here. And that's what we're trying to find. Folks, we've got to set up a proportion. And this is common sense. This, when you see these pictures, these are the easiest ones to figure out. And we're going to get more into this today. I just wanted to see what you would do with this. 6 feet, his height corresponds to what else? 12 feet. Absolutely. Because look at it. Look, I mean, seriously, look at it. It's a vertical distance corresponds to another vertical distance. 6 corresponds to 12. So if 6 corresponds to 12, then what corresponds to what? X corresponds to 3. Folks, this is what we're going to do today. Okay? You've got to pick out these corresponding sides, set up a proportion, and solve. 12 times x is what, folks? 12x. 6 times 3 is 18. Divide both sides by 12. What is 18 divided by 12? 3 halves. 1.5 what? Feet. What is 1.5 feet? His shadow. Does that make sense? Should my shadow be larger or smaller than the flagpole shadow? Smaller, of course. This is something you can use in real life. That right there. When you need to, okay? Here we go. We are dealing with similar polygons, figures that are similar. And you see that squiggly mark right there? That is the symbol for similar. Bless you. It's like the symbol that's on top of the congruent sign. Okay? Similar have the same shape, but not necessarily the same size. Okay? Now, similar, a couple years ago, I was trying to help the students understand what similarity is. To me, similarity is, what's his name? Dr. Evil in Mini-Me. Think about that. Think about that visual image. Austin Powers. You never seen any Austin Powers movies? Okay. All right, so let's change it up then. If you've never seen an Austin Powers movie, that won't make any sense to you. How about Scooby-Doo and Scrappy-Doo?
Oh, is that the Mini-Me and Scooby?
What?
Little dog?
The little dog.
Yeah. What's that, Scooby?
How many of y'all have seen Scooby-Doo? Come on.
Oh, I've seen Scooby-Doo.
Okay. Scrappy-Doo is the little dude. He's like a little miniature version of Scooby. Okay? I don't think it's his son. I think it's maybe a nephew or something.
Okay, I know.
Anyway, the moral of the story is not about Dr. Evil and Mini-Me, but it's the same shape. They look alike, but it's a miniature. How many of you look exactly like one of your parents in a miniature version? Okay, that's Dr. Evil and Mini-Me. No, that's not Dr. Y'all are not Dr. Evil, nor are your parents. But that is a version of, that's an analogy of similarity. Okay? That means if you look exactly like one of your parents at your age, when they were your age, then that's an example of similarity. Okay? Same shape, but not necessarily the same size. Not necessarily the same size. Now look at these two triangles, these two sets of triangles. This is showing you that triangle 1 is similar to triangle 2. And it's showing you symbolically with the similarity statement, triangle 1 similar to triangle 2. They have the same shape, do they not? But they are not the same size. One's small, one's large. Look at the next example. Why are triangles 1 and 3 not similar to each other? Because they're not the same shape. Clearly, 3 appears to be a right triangle, doesn't it? They are not the same shape. Write that down. Not the same shape. Okay? So how are we going to use that? 2 polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. You're going to have to repeat this back to me 400 times in the next 3 weeks. Corresponding angles, yep, really that many times. Corresponding angles are congruent. Bless you. Corresponding sides are proportional. Corresponding angles are what, y'all? Congruent, and corresponding sides are proportional. The sides are what? Nope, you didn't listen. The corresponding sides are what? Proportional. And the corresponding angles are congruent. Now, look at all this. Whew. Why'd I have to start with this quadrilateral? Look at these 2 sides. And this is a great graphic. These 2 figures, 2 trapezoids, okay? Angle A is going to correspond to angle E. They're congruent. Angle D corresponds to angle H. They're congruent. Well, right here. Angle B corresponds to F. They're congruent. Angle C corresponds to C to G. They're congruent. Corresponding angles are what? Congruent. Corresponding sides are proportional. Now, how are we going to use that? This is how we're going to use it. Identify the pairs of congruent angles and corresponding sides. All we're doing is what? We're naming. We are identifying. That's it. Okay? So, if I look at this and look very carefully, because these angle measures are helpful to us. Angle M will be congruent to what corresponding angle? Why is it angle T? Because it's flipped over, okay? It can't be angle Q because angle Q is a what? It's a right angle. So angle M corresponds to angle T. Do you guys agree? You see it? All right. Angle N corresponds to what, everybody? Angle Q. Angle P has to correspond to? Why? Because they're both 63 degrees. So we've named our pairs of congruent angles, correct? Now we've got to name the sides. All right, now how are we going to do this? Check this out. Let's look at MN. It is proportional to what? To TQ, which is, let's just put TQ for the time being. MN over TQ, because remember we're setting up a proportion. PN is proportionate to what? RQ. Very good. Why can it not be TR? No, not necessarily. It's two different sides. TR is the what of that right triangle? It's the hypotenuse, right? MP is proportional to, right, angles are what? Congruent, and sides are proportional, okay? Now, I just want you to notice something here. What's the length of MN? The length of MN. 2. What's the length of TQ? 1. Let's keep going across. What's PN? What's RQ? MP, 2.2, TR, 1.1. Do you notice anything? They're double. If you look at the bottom, if you look at the denominator, that number has been doubled and it's put on top, right? They are proportional sides. Congruent angles, angles are congruent. Sides are what? Proportional. Okay, write this down. Now again, this is all right. How are we going to use this though? Similarity is all over the SOL test, folks. All over it. So you got to lock into this. Angles are congruent, corresponding sides are proportional. Okay? What are we going to do with it? Look at this. Again, I want you to do this one yourself. Identify the pairs of congruent angles and then the corresponding side. All right, you got to have something on paper. What are the angles, Justin? A to J, yep. Okay, keep going. Right on. Keep going. How many of you had your corresponding angles correct? Good. Good, y'all. All right, how about the sides? This is where we have to really pay attention. What about the sides? Somebody go. AB corresponds to who? JG. Which is going to be equivalent to, what's next? BC corresponds to who? H, G, G, H. Doesn't matter the order of the letters. And then what's last? C, A, H, J. Do you guys agree with that? All right. Let's make sure, because if the sides are proportional, we're going to recognize something. AB is AB 10 over 5. BC is 6 over 3. CA is 11.6 over 5.8. Hey, what do you notice again? They're doubled. Will they always be doubled? Sometimes they're doubled. Sometimes it'll be times 3. Sometimes it'll be 4.2. But it's not always going to be doubled. Okay? It's multiplied. 5 times 2 is 10. 3 times 2 is 6. 5.8 times 2 is 11.6. Okay? But there is a common ratio that they share. Similarity ratio, speaking of ratios, a similarity ratio is the ratio, which is just a fancy word for what? It is the fraction of the lengths of the corresponding sides of two similar polygons. And this, I want you to look at this real carefully. It says the similarity ratio of triangle ABC to triangle DEF is 3 to 6, or 3 over 6. Notice the order. Triangle ABC said 3. Triangle DEF said 6. So they wrote 3 over 6, or 1/2. Look at the next sentence, though. The next sentence is flipped around, isn't it? And notice at the order of these. This is important. You have to pay very close attention to the order that they give you these triangle names. DEF, if they list it first, you better give me a number out of that triangle, which is going to be 6. Any number in that triangle, if they're similar, okay? What kind of triangle is that if all sides are equal? Equilateral, very good. And the side that we're going to take out of ABC is 3. But notice how those are swapped. It has to do with the names of the triangles. How are we going to use this? Folks, I'm going to tell you what, when you get your homework, I'm not answering your questions because clearly you're paying attention and you won't have any questions. Okay? Be prepared. Writing a similarity statement is like writing a congruent statement. We're going to say one triangle is similar to another triangle. And you have to list those corresponding vertices in order. Okay? It says determine whether these polygons are similar. If they are, write a similarity ratio. That's the first thing. Second thing, we got to write a similarity statement. Even before that, we got to determine if they're similar. How do you know? Oh, but they appear. Appearing is only good in ghosts and, bless you, concerts. I just made that up. That didn't make any sense. It doesn't appear. What do you know? Similar polygons have to have congruent angles, right? And what kind of sides? Proportional sides. Are all my angles congruent? How do you know? Pardon me? How do you know, though? You're right, they are 90 degrees, but how do you know? But I don't know that officially. Say it again. I can't just draw them in there. Because they're rectangles. We're told that they're rectangles. And if they're rectangles, now I have the authority to do what? Draw the boxes in there. Okay? So you need to ask yourself, first, we got to figure out, are they similar? Are they similar? Are my angles congruent? Yes or no? Yeah, they're all right angles. Second thing, are my sides what? Are my sides proportional? All right, what do we have to do? I got to figure out. How are we going to do that? No, don't have to do that. How do I? Don't the sides equal? Okay, look. You have a long side, a short side, don't you? We have a long side and a short side. Doesn't the long side have to correspond to the long side? So can I say that 9 should correspond to what? 6. Could I have written 6 corresponding to 9? Yeah, I just have to go in the right order. What is 9 divided by 6? Give me that as a simplified fraction. 3/2. Okay, let's check the other set of sides. If I place 9 over 6, then my next ratio that I have to check is what? 6 over 4, right? This is my big rectangle info over my little rectangle info. I'm using that ratio as a guide. 6 divided by 4 is 3/2. Are my sides proportional? Yes. If my fractions are the same, then they are indeed proportional. Okay? Wake up. I know. Get up, move around. But my sides are proportional, yes. Say it again, Kevin. Yes, sir. 9 over 6, which is equivalent to 3 over 2, and then 6 over 4, which is equivalent to 3 over 2. Same fractions. Okay? Now, say what now? Oh, wait, you're on the other slide. You're on that one right there. Because that's just showing you that you've got to pay very close attention when you're writing these similarity ratios, because it'll tell you, write it from one perspective to the other. Okay? That's all. It's just telling you be very cautious about the way you write your similarity ratio. Now, it says, if so, are they similar, yes or no? Yes, they are. Whew, thank God. They meet both criteria that corresponding angles are what? Congruent, and corresponding sides are proportional. All right, here we go. Let's check this out. What's the similarity ratio? It's 3/2. We've already figured it out. It is 6 over 4 or 9 over 6, which is equivalent to 3/2. That's your similarity ratio because both of them are the same. The next thing we have to do is write our similarity statement. I've got to write. Now, this is where you got to be careful. If I write A, B, C, D is similar to, what order do you have to list the next letters? Do you guys agree with him? It's E, F, G, H. If I would have said B, C, D, A, then you would have had to complete that similarity statement how? F, G, H, E. Okay? So this is pretty simple. But you got to remember, in order for things to be similar, corresponding angles have to be congruent, corresponding sides have to be proportional. Okay? It's still going to reduce to 3/2. I could have used either one, because that's what it reduces to. Okay? Questions? Let's move on. It says determine whether these polygons are similar. If so, write the similarity ratio and the similarity statement, folks. I need for you to determine whether all of the corresponding sides are congruent and all of the corresponding sides are what? Proportional. Very good. You do that one yourselves. I'm going to give you about... All right, you should have an answer for me. Oh, me. What kind of triangles are these? Very good. Very good correction. Two sides are the same. They're isosceles. So if this side, if both sides are 10, then what do you know about these two angles P and R? They're congruent, aren't they? How do I find their measures? Okay, 36 from 180 is 144. Divide it by 2, and it's 72, isn't it? Okay, so 72, 72. Ooh, is that right? It's 36 plus 144, 180, yes or no? Yes, it is. Okay. Do I need to do anything else? Why not? I did prove that they're equal. Are my two triangles similar? Why not? Because angles P and S are different. In order for them to be similar, corresponding angles have to be what, y'all? They have to be the same. They have to be alike. Okay? Since, well, first of all, are the two triangles similar, yes or no? Okay. Triangle PQR and triangle ST and W are not similar. They are not similar. No way, no how. Why are they not similar? Because my corresponding angles are not congruent. Angle P is not congruent to angle S. Angle R is not congruent to angle W, which then would mean angle Q is not going to be congruent to angle T. If I have one little piece of information that disproves something, the whole thing's wrong. The whole thing, the answer is, because if I were to ask you this, if I were to say, tell me if this is a true or false statement. Ms. Perry has taught a long time. Ms. Perry is a teenager. Ms. Perry lives in Spencer. As a blanket statement, is that whole statement true or false? Why? How do you know I'm not a teenager? Yeah, that's the part. Of course, no, I'm not a teenager. Well, look at this face. Not because I don't live, attaboy. Because I don't live in Spencer. That's a good answer, Chase. Very good. Not, clearly, I'm not a teenager. My heart age is. But my, no, not hardly. Okay? Similar or not, yes or no?
Yes.
No, they are not similar. No, that was kind of a trick question.
I thought you meant like
Sorry.
you get it.
Are they similar, yes or no?
No.
No. Does this make sense, yes or no?
Yes.
For now. Until you get your homework. And that's when y'all going to go, I don't know what I'm doing. Not going to happen. We ain't speaking that. You going to get this. Here.
Okay. That's something we get.
All it takes is one little thing. All it takes is one little thing. Didn't even have to do that. You paying attention?
What are they?
Okay.
What are they? 12.5 times 12.5.
Oh, kind of. Kind of. Hey, what's wrong with these? Look at these two rectangles. Hold up. Hold up. Hold up. Wait a minute. I don't know the rest of the song, but I know there's a song that goes, hold up. Wait a minute. I don't know what the rest of it is. Doesn't matter. Anyway. Yes, we're going to do this problem. Yes, we're going to do this problem. Okay, here we go. Are these rectangles sitting the right way? No. I need to make both rectangles sit the same way. Do you guys understand when I say sit the same way? Long ways, okay? So I'm going to turn this sucker around, and I'm going to write it this way. I'm going to throw x over here, and I'm going to throw 12.5 over here. Are you okay with that? Yep. I need my numbers even in the same spot. What am I going to do to the big triangle? Rectangle, that's a rectangle. Wake up. Wake up. No, you're not. About to fade. When I get this look, I know that look. What do I do? No, they look like I'm about to go to sleep. When you're going cross-eyed and you go really big and wide. That, I understand that. I feel your pain, okay? Here we go. Don't fall out, because I might accidentally stumble over your feet and trip and fall on the floor beside you. And then you would have to help me up. That would take half of the class. All right, so it wouldn't take half, about a third of you. What do I do with these numbers? Would I put x over 12? Can I throw 12 over here on the left and keep 18.6 up here on top? Why? Because in rectangles, opposite sides are congruent. Right on? That was what that means. I got you. I got you. How about this? X corresponds to what in the big rectangle? 12. All right, so I've got little rectangle information over big rectangle information. I'm using that as a guide. What's my other little rectangle number? 12.5, which corresponds to 18.6. Do I know how to solve that? How are you going to solve it? It's a proportion. Cross multiply. 18.6 times x is 18.6x. What's 12 times 12.5? 150. Now what, y'all? Divide by 18.6. And it's going to be? Go ahead and say it. 0.645, blah, blah, blah. Right? Oh, okay. Justin has decided we are going to round to the nearest tenth place. Attaboy, Justin. Take charge, man. Take charge. Do you guys agree with that? You agree with that? You have it on your paper? Okay, you promise? Don't lie to me. Okay. Here we go. Any questions on this? Is this facile or difficile? This is facile. Like, bring this on, right? That was kind of weird. But you know what it is? You know why it's kind of weird? Because it's kind of like a proof. Okay? Hey, what about this one? ABC is similar to DEF. Now, let me tell you this. That means that AB is going to be proportionate to who? DE. Oh. No, it isn't. But the picture is. Now, here's my thing. Here's my warning. When these pictures are not sitting the right way, because that other one, I could make it sit the right way, right? Yeah, and y'all know I'm sitting the right way. You've got to, this right here flips me out. I'm like, oh, good Lord, what in the world? And you guys can sit there and go, but Miss Perry, just turn your head. Just redraw it, turn it this way. I cannot do it, okay? So this is when I have to rely on my similarity statement, okay? AB is proportionate to DE. We're going to find out what EF is. BC is going to be proportionate to what? EF. Very good. All right, so I got AB. That's done. I got DE. I got that. I got BC. Let's mark it off. And EF. Hot daggone. 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 Am I ready to figure out what this side is? I've got to find, do I need it? What am I looking for? EF. I don't need that other side. I already know that the two triangles are similar. Okay? So, how am I going to set this up? What is AB? 12 over 19.2, 15 over x. Hey, solve that real quickly for me. Hey, how many of you got 24? Hands up. Rock on. High five in the air, y'all. Very good. Facile or difficile? Facile. If the two figures are not sitting the right way, then you need to rely on the what? The similarity statement. That is beneficial to you. Okay? Look at the next one. Oh, how many more?
Lot.
Just 3. Okay, rectangle. Ooh, what's, all right, I don't even need to look at it. What's missing? Picture, picture. Draw it. I know. Zoe, you were impressed by my cheering skills, weren't you? Rectangle. 3.2 wide. 8 long. Okay, look. I'm putting W and L up there for me. Okay, it's going to be a guide. It says a similar rectangle is 5 centimeters long, so I'm going to have to put it where the L goes. Okay, you with me? What's the width? All right, now, folks, I'm telling you right now, these W's and these L's, I put them there as guides. How am I going to set up my proportion? All right, hold up. Brandon, go, because you said first. 3.2 over X is equal to, come on now. Right on. Hey, get this. Okay, cross multiply. Thank you, dear. 8X is equal to, what's 3.2 times 5? 16? Divide it by 8, what do we get? Say it again. Hold up. Say it again. Okay, good. This is going to lead us into a good discussion. All right, but similar polygons, similar rectangles, similar triangles. Corresponding sides are what? Proportional. Okay? So I need to put my corresponding sides information over each other. Why did it work out? It could have just so happened to have worked out because of the numbers that we had. Is it always going to work out that way? I can't guarantee that. Okay? So you would be better off setting up proportional side to proportional side equal to proportional side over proportional side. Corresponding side over corresponding side. Okay? I cannot guarantee that that's going to work every single time. Question? Oh, it's still going to work. Because look, X over 3.2, that's a good question. 5 over 8. I still end up with 8X is equal to 16, which is 2. That's a good question. Very good question. Okay? Yes, sir. You can, if you want to. Plugging it back into the proportion. Well, it should. Because 3.2 divided by 2 should be equivalent to 8 divided by 5. Okay? All right, look at the next one. Triangle MNP is similar to triangle QRS. And the ratio of MNP is 5. QRS is 2. If MN is 42 meters, what's QR? Holy moly. That is a lot. How do you think we'll set it up? Just out of curiosity. How do you think we're going to set this up? Come on, folks. (42 over X is equal to 5 over 2. You guys buy that? Yeah. So cross multiply. 5X is equal to 84. 84 divided by 5, what is that? Say it one more time. Is it straight up 16.8? Hey, does that make sense? Should that side QR be smaller? Yeah, it should be smaller. Do you guys agree with that? Yeah, cool. Is that easy? It kind of is. Kind of is. It looks kind of weird, but once you get it set up, it's a piece of cake, isn't it? Look at the next one. Triangle HJK. Again, no picture. What do I need? Picture. HJK. Side lengths of 21, 17, 25. The two shortest sides of triangle WXY, the two shortest sides, and let me just say, shortest sides should correspond to shortest sides, right? Okay. Where am I going to put, where are the two shortest sides in triangle JKH? 21 and 17. Those are my two shortest sides. My shortest side, though, is 17, right? Okay. What's the shortest side given here? 48.3 or 39.1. So I'm going to put 39.1 so that it corresponds to 17. Do you guys agree with me? Do you understand why I'm putting it there? Then that means 48.3 is going to go, it's going to correspond to 21 because it said it was the shortest sides. So 48.3. The two shortest sides of triangle WXY have lengths 48.3 and 39.1. If HJK is similar to WXY, what's the length of the third side? They are already similar. What's the length of the third side? It's going to correspond to 25. So do you think we might use 25 in our ratio? 24 over X. Who said that? Amber. Amber finished that. And Cody, how else am I going to finish this?
Do I put the 48.3 on the top, 39.1 on the bottom?
Because it's out of the same triangle.
Oh, yeah.
25. Now look, some of you have to move to get this. Check this out. 25 over X should be, I got to follow the same motion. 21 over 48. I could have used 17 over 39.1. You can use either one of them as long as you choose the correct corresponding side. Okay? I'm going to go, watch this again. 25 over X is equal to 21 over 48.3. Solve real quickly.
Does it matter which one I'm going to talk about?
If I go with this triangle on top, Cody, HJK, then I've got to have that other one, WXY, on the bottom. All that information has to be on the bottom. Okay? And again, watch that motion. 25 over X is equal to 21 over 48.3. It should be a big number. Oh, that ain't right. What is 25 times 48.3? La la la. Shh, shh, shh. 1207.5. Quit beat. How many of you got 57.5? There we go. Fix it. Fix it. Did you use 21 over 48.3? Y'all have more. We're going to save it for tomorrow. Hang it up, okay? Now, folks, I'm going to tell you what. You're going to have homework. You just better suck it up, okay? Here's what you're going to do for me. And we're going to roll through this. So you better be here every day. You better do your homework and you better ask questions. I don't know. We'll worry about that later. I want you to look at page 465. And folks, if you can't do my homework, you know it's going to make me mad. Not that you care. But I'm just telling you, be prepared. I want you to do number 7, number 10, and then I want you to go back and do try number 11. Yep. That's 3 problems, y'all. That's all I'm asking you to do. 3 problems. Okay? Do it and start it now. And don't ask me questions. Look back in your notes because this is all straight out of your notes. Your notes come from your homework assignment. Okay? You can do